The Lounge, proudly brought to you by Johnny Walker. Keep walking.
Good evening, welcome to The Lounge. My name is Kweku Sechiado. And The Lounge is brought to you by Johnny Walker, Keep Walking, and it's recorded at the Equator Bar at La Palm Royal Beach Hotel in Accra. Nothing harassed and destabilized me in my secondary school years as maths and physics did. Trigonometry, linear equations, calculus, algebra, velocity, magnetism, oscillations, BODMAS, SOHCAHTOA, these made me unhappy. Somehow, I wasn't that bad with chemistry or biology. I don't know why. But the dislike for maths and science apparently is phenomenal among students in Ghana. And yet, numbers count, literally. And our understanding of these scientific concepts enables us to know ourselves and conquer our environment and make more of our limited days on earth. So if math and science are that important to our survival as humans and the development of our societies, then why must it be so complicated for so many? Who's got the formula wrong? Is it the teachers or the learners? Tonight, we're taking math and science out of the classroom and bringing it to a bar. We want to solve the math and science problem over drinks and finger foods, having failed to do so, eating the tips of our pens and pencils in class. I've got an excellent panel tonight. Lucy Quist is an engineer and chief executive of Airtel. But more importantly, she's a strong advocate of science, technology, and math education, or STEM, especially among girls. Jane Egerton Idehen is a Nigerian engineer. She works with Ericsson, the telecommunications company in Ghana. She loves, always has loved, maths and science and want to explore whether it was taught differently in Nigeria. And then finally, we've got Professor Sichofe Anku. He's a mathematician. I just love the sound of that. You know, when your passport reads profession mathematician, it's just smart. Prof. Anku runs a private math academy called Mikasa Math Academy, and he's also the president of the Ghana Mathematical Association. So I've got an excellent panel, and if you have any math problems, you've had any math problems over the years, hopefully tonight it will be broken down and we'll have a better understanding of math and science and their importance to our survival and the development of our society. Welcome to The Lounge. So, welcome to Math in a Bar.
Thank you, Kweku.
So, you know, Lucy, obviously you're good at math, right?
Yeah, if I could say so, I guess, yes.
Yeah,
I have to be.
You have to be good at math to have become an engineer, mechanical, electrical engineer. What made you like maths? What made you good at maths, you think?
I think the first thing is that I never had the opportunity to think of math as tough. And when I think about it, that's probably one of the factors. So my dad introduced me to a lot of mathematical principles from a very young age. I always tell people
what did he do?
So he literally did math with me. So
was he an engineer?
He's an engineer.
He's an
yes.
engineer.
He's same electrical and electronic.
Okay.
And when I say he introduced math to me, you know, children can be easily conditioned one way or the other, is the way I believe. And what he did with me is that he did a lot of math problems with me. So he'd even do topics that I was perhaps sometimes too young for. I always tell people about my example of doing algebra at 8, and I really didn't understand how you could combine numbers and letters. For an 8-year-old, you know, you just probably managed to start reading and so on. So I didn't get the concept of combining letters and numbers, but because he had kind of pushed me so young at it, later in life when I came to do algebra, it seemed quite straightforward. So one was not knowing that it was supposed to be difficult. So it was seen as, you know, something we do. And secondly, I think that once I got into it, you know, that moment when you solve a math problem and you go, yes, it's just euphoric. So, you know, you keep riding on that. So it's like a trophy,
which then
you just love it.
Motivates you
absolutely
to do more.
Exactly. So math is fun, is essentially what I'm trying to say. It can be fun, and we need to make it fun for people at the youngest age possible.
Did you find, while as a student, you know, obviously you were having fun, but I'm sure you did notice the laggards. Like, if I was in your class, I would have been one of them.
No, you know, I think that it wouldn't be fair to call people sort of laggards. I think that first point I made about conditioning is extremely important. So if you're in class with someone who's been conditioned otherwise to say it's difficult, then it's about working together. So students equally have a responsibility, not just teachers, with their fellow students to help them along. If you're finding it more fun, why don't you make it fun for the other students in your class? So I enjoyed also the fact that it gave me the opportunity to engage my fellow classmates. This whole thing about conditioning, whether it's teachers, whether it's parents, whether it's grown-ups around them, I think it's an area we need to address, because sometimes we pass on our own fears and our own concerns to children who haven't had the chance to, you know, explore for themselves. And maybe if I was afraid of math at the time, I would have encouraged him and said, yes, you're right, it's very difficult and it's going to get much harder beyond class 1, so give up while you're ahead. But I didn't. So I think there's definitely a role there for encouragement.
Prof. Anku, so do you recognize that math, the learning or teaching of math and science is a phenomenal problem in Ghana?
Yeah, thank you, Kuku. I want to make some comments, you know, on some of the things you said first.
Okay.
Now, it is Ghana Mathematics Society.
Okay, not association.
No.
Okay.
And then you also talk about mathematics being complicated. I don't say mathematics is not complicated.
Not for you, because you're a professor of math.
No. Mathematics is not complicated. We make it look like it's complicated. It is not. It's a very, very simple subject. And I guess it's the easiest subject for students to learn. You see, there are certain things that are missing, like the conceptual understanding of mathematics and relating mathematics to real life. These are the things that are missing. So you think mathematics is coming out of space. It's not coming from space. It's everyday things we do. You see, so we claim that everything you do contains mathematics.
Is there anything that's complicated in life? Because if we say, oh, it's not complicated, it's very simple, then that assumes that everything, you know, nothing is complicated. I mean, of course, if you master it, it's not.
I think it's the approach we adopt. That's why we make it look like it is complicated. What I'm saying that the subject mathematics is not complicated. You see, there are some fundamental things if we understand them.
If,
see that?
Yes. If everything is possible, if we understand them. So how come we don't? How come so many people don't understand these fundamental things?
Yeah, it comes from, you know, there are many factors, you know, involved here. I'll spend the whole day talking about
No, don't. Simplify it.
Yeah.
Make it easy, like math.
Okay, you see, now, you see, teachers are part of the problem. The students are a major part of the problem. The curriculum is part of the problem. The textbooks we use, part of the problem. There are many things that,
Let's start with the teachers. So what's the problem with the teachers?
With the teachers, most of them don't understand the mathematics they are teaching. Most of them. And they carry the fear they have themselves to their students.
Yeah.
They intimidate them. It's in the classroom. So from the very beginning, they begin to hate the subject of mathematics. When they see the teacher come in, mathematics teacher, then they freeze. Nothing gets in. But you see, if you adopt...
There's nothing more distressing than a 2-period math class.
Yes.
Just before lunch.
It is true, you see, but
you are hungry, and Duse Anthony walks into the class.
Yes.
Or Struggling Man, I can't remember, we had a math teacher called Struggling Man, walks into the class. And it's one of those long periods, 1.5 hours before lunch.
I will tell you.
And you are 13 years old.
I will tell you a particular, case that happened. I organize camps in my academy. Students come all the time for camps. And there was a time in our camp, we start at 7:30 in the morning. They go for morning devotion. Then they go for the math itself from 8 o'clock to 12, non-stop mathematics. Then when it's 12 o'clock to 1 o'clock, they have lunch. Then 1 o'clock.
4 hours non-stop.
4 hours non-stop mathematics. And
in your academy?
Yes. When they come for camp. And then when you go for, after the lunch, you go.
That's frightening.
Let me tell you something. From 1 to 5 o'clock, 4 hours, another non-stop mathematics. So when they came, if that doesn't end there, then after lunch, after supper, they go 6 to 8 o'clock, another mathematics. So it's 10 hours a day, continuous mathematics.
Okay, why is that a good idea?
No, let me tell you. When we started the first 2 days, the teachers who brought the students to the camp came complaining to me that, Prof, are you not wicked? Why do you keep these students for so long? They have got short memory.
Short attention span.
Attention memory, that's what they told me. Then, after some time, because there were about 30 teachers surrounding me alone, I had to give in. So I said they should give the students a break. So after, about 10 o'clock, they gave them 15 minutes break before you go for lunch. The third day, then when it was time for lunch, the students didn't get up. They were still working. Then I had to go and ring a bell to stop them. And they raised their hand, told me I was disturbing them. The same students who had short attention span, within 2 days, they now develop a long attention span. How come? The same students.
And they were enjoying it.
They were enjoying it. That's the thing. If you're understanding and enjoying, you don't get, you continue.
So when you're saying, so the teacher, back to the earlier point.
Yes.
It's about the teachers. Some of the teachers themselves don't understand math enough.
They don't understand it.
I think it was Einstein who said, if you can't simplify it, you don't understand it.
Yes.
So that's been part of the problem.
Then the curriculum, you said the curriculum as well?
Yes, and the textbooks they use. All of those things put together, they are all problems.
In a sentence or two, what's the problem with the curriculum?
Curriculum is too loaded. It's too loaded for what students must do for a period. It's just too much. And it's just theory. And it doesn't make sense to them. So they get bored very quickly and they, tune off very quickly. So because of that, you see, what I do at my academy is what we call practical mathematics. The students do the work themselves. We don't tell them area of a circle is pi r squared. We take them through activities, they themselves come in. Before they realize they've written down the area of a circle is pi r squared. They write themselves.
So they discover
the thing themselves through activities. So they are always very excited, happy, doing so many things. So they don't get bored. You see? So the way we teach is part of the major problem.
Then another thing you said is the students.
The students.
Also the problem. So what's the problem with students?
Most students these days don't focus. They are on WhatsApp all the time.
But I didn't have WhatsApp.
You didn't have WhatsApp.
Well, I didn't have WhatsApp
I'm
in
talking about what's
secondary
happening now. You see, a lot of them are on WhatsApp, gossiping instead of studying mathematics. They don't study mathematics.
So basically, we were not. I mean, again, it's not just students of today,
Yes.
but of earlier generations as well who also struggled, such as myself.
Yes.
So maybe we're not paying enough attention.
Yes, you don't pay attention. You don't focus on mathematics. You don't practice mathematics. You know, you just wait for formulas to give you answers. We don't understand what you are doing, how to relate to real life. For it to make sense for you to enjoy it. See, you go and learn multiplication table in the classroom. You know, 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 5, 15. You go to the market, you know, 5 heaps of tomatoes at 3 cedis each. How much? Then you don't know. You don't see the connection. But you know 3, 5 is 15. But the same, it's the same 3, 5. I cannot see the link, the connect. You don't see it. So that's that problem. So students don't study to understand, you see. So there's that problem also for the part of the students. And like I said, it's all over, all over. We made the whole thing look like a terrain that you dare not go.
You're watching The Lounge. We've brought math and science into a bar. We're taking a quick break. We'll be back shortly. Welcome back. You're watching The Lounge, where we've extracted math and science out of class and we brought it to a drinking bar. We tried maths sober, it didn't work. We're trying it over drinks. And I've got an excellent panel. Lucy Quest, who is an advocate of science, technology, and maths, especially for girls. Professor Sichofe Anku, who runs a math academy and also heads the Ghana Mathematical Society. And we've just been joined by Jane Egerton Idehen.
Yes.
She is an engineer herself.
Yeah.
You're an electrical engineer?
Yeah, electronics.
Electronics,
Yeah.
excellent, excellent. Nigerian, she works with Ericsson.
Yeah.
Was math taught differently? Or do you recognize what we're discussing in your own education in Nigeria?
I could draw a lot of parallels because I was listening to Prof and I also listened to Lucy. It wasn't really taught differently. So he's kind of right. Part of the problem is the method it was taught. I will give an example. When I learned tables, like he said, the multiplication tables, I was taught to memorize it. I had to memorize it. I didn't really have a proper understanding why we were multiplying. I just knew that I had to know the tables till 12. But when my son was taught the tables, he learned differently. He learned to add it. And that way you could understand the concept. He added the hips, like he said. If you add a 5 and a 5 and a 5 3 times is 15. That's 3 times 5. So in that way he could understand it because it's like applied math and he can relate. My daughter is 6. She's learning the tables in a different way. She's learning to add. She adds in 3, she adds in 5, she adds in 2s.
So
that could be...
Right. So it should the other way around, because then that way you then understand it
You
better.
can understand because it's applied. You can relate it to real life situation. We can say, bring your toys. Let's group them in 5s. Now let's count them. And once you do that with a lot of frequency, you kind of index the memory. So you can actually tell 3 times 5 is 15 without learning, even being forced to memorize it without learning how to apply it.
Right. So how come you learned to love math and science?
I think I would say I kind of fell into it. So yes, I decided like an earlier age that I wanted to study engineering because I heard someone talking about it. Okay. My mom was talking with a friend and they said it was very difficult. And I said, I'll do it because I just love the challenge. But the reality, like I tell
Your
people,
parents, scientists or
no scientists. My parents ran a bakery. There were no scientists. I think at that time I wasn't aware, but I was normally intrigued by a challenge. And now I am aware that that was the attraction. The fact I heard people saying it was difficult, that was what attracted me. Not the fact that I knew what engineering was. But the interesting thing, like I always say, when I first did my first physics maths test, my first physics test, I got a 0. I always tell people, I ended up with a 0. Because I didn't understand, like he said.
And it didn't
I didn't
break
know the
you?
trick. Of course it broke me. We talked about it. We laughed at each other. Half the class, left physics. The remaining of us were like, we're hanging there. But when I found the key, like he said, practice and understanding your learning style. Because later on I found out in life that my learning style required that I discuss. I shouldn't be fed one way. It should be a communication. If I can chat back and say, okay, this is what you're trying to say, is this how we can apply it, then I will understand better. And that was the trick.
I can definitely relate to that I found that discussing with other students and practicing together was definitely some people have a more visual style of learning, some people need interaction. There are people who can lock themselves away and just learn on their own. Whatever your style is, there's a way to crack any subject, including mathematics. If someone has to study literature, you don't read your literature book once, right? There's no way you're going to read Dilemma of a Ghost once and go and write your exam, right? You'd have read it a number of times, made notes, gone over, what was the dialogue, who said
think
what,
about it.
You think about, you'd capture that. But why is it that we don't want to apply that same principle of practice to math? I think it goes back to this fear that's inculcated in people that says it's not even doable. So it doesn't matter how many times you try, you're not going to get it anywhere. At least Dilemma of a Ghost, you can read it and get it because it's in English. You're not
Plus
going to get it.
It's a story.
It's a story, right? But
it's a story. You watch a movie, you love it, it's fun, there's, tension, there's violence, there's love.
And you can relate to it.
Yeah, it's a story,
you're right,
but these are numbers.
Yeah, but you see, I think that when we have these discussions about mathematics, I think sometimes it feels as though there's an assumption that everybody has to study maths to the extent that they become an engineer or a scientist or an astronaut or something. I don't think so. I think to Prof's point, first of all, maths is a practical aspect of life. And if we can embrace it better, we will understand the world around us better. We will understand life better, right? When I talk to children, I give them exactly that example that they tell me that math is difficult. And yet, I don't think any of them come home from the market when their mom sends them to the market with inaccurate change or inaccurate goods. They don't. They come with exactly what their mother says, 5 of this, 10 of this, 8 of this, but they will do it, they'll bring the change, they'll calculate it. So if we can make it more practical rather than just the answer, but what is it for, they'll embrace it. The second thing is that we have to break it down so that everybody finds their place in math. In today's world, everybody needs a degree of comfort with STEM, and the foundation of that is mathematics.
Is there a gender sort of problem with math?
Not here today.
Well,
not here today, but there's a perception.
Generally speaking,
I don't believe that.
You don't?
No. Everybody can do mathematics. It's one of our principles. Everybody.
But what's the reality?
The reality too is that people can do, everybody can do it.
Yes.
Well,
Yes,
I think from an ability point of view, I agree with you that I always tell people that ability isn't gender specific. Yes. However, what we experience in real life is that girls are disadvantaged.
They are discouraged, that's all. Not that they cannot do it, they can do it, but they are just discouraged.
I understand, but the reality is that whether it's discouragement or disadvantage, they aren't participating as much. I think, but Kweku, I have a theory that this issue of under participation of girls in STEM, specifically mathematics, is actually an effect and not the cause that we're dealing with. The truth of the matter is that formal education by design was actually designed for boys. if you go back to some of the oldest schools anywhere in the world, the old thinking used to be boys go to school and girls don't go to school, right? So that's why we still have initiatives to even get girls into the classroom. So you have
a long time ago.
We still have that issue though, because there are many countries now where the best schools in the countries are for boys.
Oh.
Many countries, right?
Okay,
where the
many
best
countries,
schools
okay.
are for boys. This is something I've researched. So you say it's a long time ago, but we have countries where, for instance, boys were going to school for hundreds of years before girls come in. Now, what does that do? It creates a representation issue, that boys have more examples of men who have done these things than girls have done. Now, if you take the fact that there was this whole concept of boys go to school, that we're overcoming that, and then you overlay it with this fundamental fear that this whole mathematics thing is difficult.
Scary.
You're not going to put the girl who you've just allowed into school, encourage her to say, go and do the hardest part of school. You get the thinking. So what we need to demystify is that school is for everyone, right? And we promote that a lot in Ghana. And the STEM and mathematics are for everyone. But these are some of the barriers we need to overcome, that we fundamentally got this thing that girls don't go this far in education, and so you don't go too far in the harder part. After all, you know, you're not going to become an engineer, you need to do something else, and it doesn't require this math, so it's not for you.
But don't you think this is changing? I mean, today with all the girls that are doing excellently in schools and universities, who are becoming doctors and architects and, you know, and,
they're still out there,
and who are in technology such as yourselves and so on.
they're still largely, to some extent, outliers, right? I recall, I mean, I don't think I'm that old. When I went to Presec, I think in my year there were over 200 of us, about 38 who were girls, and the science class was even smaller than that number, about half of it. So in terms of representation, the girls who are demonstrating and women who are demonstrating that it's possible, but we need to get more young women and girls to see these examples, because they need encouragement that says, okay, I'm not alone, I'm not the first person, it won't break me, she got through it and she got through it, so somehow I'll get through it as well. I believe, because experiencing it, I must admit from personal experience, in that classroom, in that math classroom, in that science classroom, there is still a bit of a feeling of, what are you doing here? And what are you doing there here is not a good feeling, right, Jane?
It's not. I'll give you this is my own personal take. When I studied engineering, in my class there were 100 people. There were only 10 girls. There were just 10 of us. We're still very, very far away. And this is all the way in Nigeria. Still very far away.
Yeah, but if I may ask, were the girls prevented from joining the classes?
The girls were not prevented, but there's this, it's more like a cultural perception that it's too hard for girls. So people are kind of gently nudged away from it. The first time I told one of my uncles I was going to study engineering, like, what? Engineering? You know, do something, banking, finance, come and get married. There's all these subtle messages people throw along.
It's a mindset problem.
Yes.
You know, it's a mindset problem, and it's not the issue of the girl child cannot do mathematics.
No, so that's what we're saying. The ability is there, but the cultural perception is shaping all
that's
this.
what must be disabused. Yeah. Whose mind must be disabused from that? Because you see, we are putting food at disadvantage. I tell them, you are a girl, so you cannot do mathematics. No, it's wrong. Because I've come across many brilliant girls, but I've done very well in mathematics.
In fact, maybe it's a good time to tell us about some of these STEM institutions around Africa.
No, absolutely. I think that, before I respond to Prof's point, you're right, Prof, but that's why we have conversations like this. So hopefully, if a young girl is listening, if a mom, a dad is listening, a teacher a teacher is listening, they will encourage that girl. Every time my teachers applauded for me, I was happy. They didn't tell me I'm clapping because you're a girl. They said, I'm just happy that you cracked it. But because we still have some of these challenges, I think I'm very proud to see across Africa that their initiatives to encourage more girls into the sciences. So for instance, you have the African Science Academy at Tema. I was there earlier this year during to give a speech to the girls during the launch. It was a launch event, but they're already running.
And this is an institution just specifically for girls?
It's specifically for girls.
Is this the institution set up by the Nigerian philanthropist?
Yes, so Tommy Luby. Tommy Luby is an entrepreneur, entrepreneur and philanthropist, British Nigerian, and he set up African Science Academy. And the beauty of African Science Academy at Tema is that it hosts girls from all over Africa. So you've got Ghanaians, you've got Nigerians, you've got Somalis, you've got Ethiopians, you've got Ugandans. So basically these girls are suddenly here in Tema. So basically you're getting girls experiencing a cohort of girls like them studying science and mathematics, which is brilliant. So
it's for a year.
It's for a year, and it's for a year to prepare them to the next phase, which is university. So it sort of finishes off their mathematical ability and skills and things that they need to really take math to the next level. Because as you go up the ladder, people drop off from the sciences and maths gradually. This is really designed to keep them going, strengthen them, build some of those those skills and competencies. That was a brilliant experience to engage these really smart girls, but also girls. And I emphasize the word girls because in addition to doing their science and mathematics, they also put on a beautiful cultural dance. So this whole thing of if you're doing science and mathematics and all the other, you have to be a nerd or you have to be a certain way. These girls are not like that. They presented actually their cultures from their various countries very proudly.
So mathematicians can dance.
Mathematicians can. I think they know how to dance better because they get the moves. But Koko, there's another example that I visited in Rwanda. Gashora Girls Science Academy. This is a secondary school, full secondary school. They had 290 girls when I was there. And their performance is absolutely astounding in terms of what the girls are able to achieve, the grades they're able to achieve that are internationally recognized, right? So you go there, and I was with the girls and they told me about what the education in STEM had done for them, how it had brought them out. The girl who showed me around said, before I came here, I couldn't talk. I didn't have the confidence to open up and engage people. I'm engaging you now, but I wouldn't have done that a while ago.
How old are these girls?
So these girls are at the beginning of secondary school, 12, 13, and they go all the way to the end. I met one girl called Stella, and it was such a proud experience to be in the presence of this young woman who had just finished Gashora Girls. She's gotten admission into 10 different universities in America, all to study STEM, and 5 of them were Ivy League. Right?
Wow, that's very good.
Right, so she had gotten into Harvard, all
scholarship
these
and all that.
It's like, so literally I went to the school and there was a board and the students were like, some were voting, some were saying to me, you have to tell her that the schools have to apply to her. They should apply to her for acceptance. But the point is that it is possible because this is African Science Academy, Gashora Girls are examples of people saying that, we believe that ability is not gender specific. We know that there's a gap, so we're going to create these places where we encourage more girls to, in the safety of being with other girls, learn more science and mathematics, but learn it practically, so it really actually has a real impact on their lives and they can take it forward.
Can I add something to what she said? Because now we look at it from the level of the girls. We also have a big challenge, the women. So when they start the career in STEM, we see that they also thin out nicely. Like we lose almost half of them. At the end of the day, you see very few women in STEM still hold the career in STEM. And that's part of the issue. Because I personally, like she said, sometimes we've created work with men in mind. And we're bringing women into this field, or at least since after the Second World War, we've seen a lot of women plunge into fields like STEM, but we still want to create the same environment we created with the male in mind. These are women that would have kids if they do get married. So it's natural they'll go on maternity, they'll take maternity leave. And some of these jobs...
But that after maternity, there's life. They can, and in fact, should, and many do return
back. But the challenge we tend to see is that sometimes the environment does not make it easy for them.
You're watching The Lounge We've brought math and science into a bar. We're taking a quick break. We'll be back shortly. Welcome back. You're watching The Lounge, where we've extracted math and science out of class and we've brought it to a drinking bar. We tried maths sober, it didn't work. We're trying it over drinks. Let's take a moment and toast to authentic whiskey. Let's toast to Johnny Walker, the original taste of whiskey. Since 1820, Johnny Walker has remained the world's #1 Scotch whiskey and has won numerous awards for excellence. This is because the impeccable formula of distillation has been jealously guarded over the ages, thus its distinctive taste. Johnny Walker comes from an intricate blend of a wide spectrum of carefully selected flavors, giving it savored by millions all over the world. So let's toast to the unquestionable taste of whiskey. Johnny Walker, the whiskey the world knows best. Johnny Walker, keep walking. Drink responsibly, not for sale to persons under 18 years and pregnant women. And my guest, Lucy Quist, STEM advocate, mathematician, engineer, everything. She's just great. She can dance too.
Yes, she can dance very well. I can attest to that.
And I can tell you that Jane can dance. When we're done, we should play her some salsa.
Oh, now you're dancing. Yes.
Oh, you should see Jane on the dance floor doing salsa. You know, she's got.
That's good. It's good. So with this,
I've got two left legs.
Oh.
Yeah, you know, Prof. And then of course we've got Prof. Anku, who is a mathematician and is president of the Ghana Mathematical Society. So, Prof. Let me just check the time. Okay. Good. So, Prof, well, and all of you, let's give me a mathematical problem, help us solve a supposedly complicated math problem, and let's see what it means, why it's important to do this.
Okay. You see, there are many things to say, but I realize we don't have time for all of them. You know, I have to lay foundation for many things. Like, there is a fundamental question of mathematics that we don't explore. That fundamental question is simply how many? How many? Answer that question, how many, will lead you to all mathematics. Or how many, you know, suggest counting. You must know how to count. And to be able to count, we must develop number systems. So on and on and on you can go. I've got a whole lecture on this if I want to go through it. You know. But if we talk about how many counting, you remember the elections were all about counting.
Yes.
All about the counting. I was telling people that we went to court 2012 because we didn't know how to count well.
Because we didn't count properly.
That's what happened. Seriously, we didn't know how to count well because place value, all those things came in. We didn't know how to do them well. You see, we didn't do them well.
What's place value?
Place value is the value of a digit depending on the position it occupies in the number you
unit,
write.
10, 100.
Yes,
okay,
that's
so,
it.
Okay, that's place value.
So
okay,
there was a very serious
my 8-year-old is doing that already.
Yeah, there was a very serious issue about this place value thing. It was a conflict between the Joy FM reporter and one party. Seriously, you know, they reported 5,268. The person wrote 5,286. All the digits were there, but the places changed. They gave different value. You know, so it became a conflict. You see.
So you can. So if you get your maths wrong, you can.
Very serious. It
can lead to civil war.
Seriously. Seriously. If you listen carefully, the last election, when the electoral commission was giving the percentage of those who whatever, and there was a serious mistake, You know, all those things can create a lot of problems. It's just mathematics. I remember advising them they should get who are mathematically literate to count at the polling stations to prevent any problem. And you remember they said the accountants who should go and count, do whatever. It prevented a lot of the problems. A lot of problems. Because first I didn't count well. That's why we got problems. So counting is very, very important. And you see that all of mathematics can be reduced to arithmetic. All of mathematics. Calculus, call it whatever, can be reduced to arithmetic. So you must understand arithmetic. The arithmetic comprises addition, subtraction, division, multiplication. All these are related. They are all related, you see, in a way. So if you understand them, that's why I focus on fundamental understanding. If you understand it, the way is so clear for you. So when it comes to this Sokatwa thing you are talking about, that
My Sokatwa.
Yes, which confuses,
sounds like the title of an album.
Yes, which confuses students, is trigonometry. What's trigonometry? It's just the ratio of the size of a triangle. Sine, cosine, tangent. That's all. The ratio of a size of a triangle. A ratio, what's the ratio? It's one number of another number. That's all. You see? So, if you want to use this concept, like what's tangent? Is a ratio, you have a triangle. You have a, what they call a right angle triangle. And you want to find the height of a tree.
So we've got, so Prof has got another, he came along with what's his name?
Benjamin.
Ben. Okay, so Ben is at the flip chart now. He's got his marker and he's working some, okay, right now he's drawing a tree. So what are we solving now? You are applying Sokatwa.
Yes, we want to find the height of that tree. You want to find the height of the tree without climbing the tree.
Okay.
Using your mathematics that you have learned. Okay. If you understand it, no big deal. So
there's a tree, you want to know the height of the tree.
And for that matter,
but you can't take tape and climb the tree and use the tape to. So how do you?
Some coconut tree or whatever it is.
All right.
You know, or any building.
Right.
You want to find the height of it. So you have the tree, and then you have
a man or woman standing there near the tree.
Yes. And then what you do is you measure from the foot of the tree to where you are standing. Okay. And then you take what you call a clinometer. A clinometer. And you look through it and you find the angle, mark the angle theta. You find that angle theta from where you are standing. And you look at the top of the tree. So then you know the distance from where you are standing to the foot of the tree. So you see that the height of the tree is that h1 plus you, the person doing the measurement, your height h2. Does that make sense?
It's
the height of the tree.
It is slowly.
Okay. The height
of the tree, yes.
Show you the height of the tree, h1.
h1, yes.
Maybe
okay.
No, the height of the whole tree.
He's put h1 there. Yeah. Yes. There's h1.
It's equal to h1 plus h2.
h2 is the height of the man.
The tree. Yeah, the height of the man.
And then h1 is from the man to the top of the tree.
So h1 is from the top of the man's head to the top of the tree. And h2 is the height of the man.
Yes. Because the concept tangent can be used to find that h1.
Okay.
So the h1, because you know that the ratio of h1 to the distance from the foot of the tree to you is the tangent of the angle theta. And you have already measured the angle of the theta. You can find it from a table calculated, is already there. So you can find h1. If you find h1, you add it to your height, h2, then you find the height of the tree.
We can make it easier and say theta is 45 degrees.
Yeah, whatever. You know, you can make it easier. Okay. But I'm just showing the general way of getting it done. And the clinometer you create yourself by your students. You create yourself.
Okay. So and the clinometer is what?
Pardon?
The clinometer is what?
It's what you can use to measure the angle.
Okay, and how do you create it? Explain.
It's just like the protractor. You create, you know,
you fold. Go on.
I wanted something round. So.
Okay, yeah.
Something like this. It's a protractor, right?
Okay, so you are holding the, what you call it, the coaster.
Yeah, yeah.
The round, the circular coaster.
Yes. Then you measure the angles all around. You know, it's 360 degrees. You put a needle in here, and then you have a rope with some stone on it. Then there is, you know, something on top here you can look through with your eyes. Then you estimate the height from there. And as you are turning this will be turning.
The thread?
The thread will be turning. So it will measure the angle theta for you.
Okay.
So you now know the angle theta.
So you can actually just make a
Exactly.
game.
Exactly. It can be very practical.
And it's fun.
Right.
They enjoy it. You find the same tree, you ask 3 groups of students to go and find the height of it. And they come up getting almost the same answer. So it means that you are applying your concept of tangent that you learn. You know, that the opposite side over the, you know, sorry, the opposite over the adjacent. That gives you the tangent. That's all.
So if you want to know the height of a coconut tree, you don't need to climb it.
You don't need to climb it. You just stand somewhere and do it. Use your mathematics and find the height.
Math or the height of a skyscraper.
That's all. You can do all of those things.
Okay.
You see?
So back to counting and the importance of math. Maybe we can wrap up. Thank you, Benjamin. Thank you. What do you do, Benjamin? IT. Sorry? IT professional. Oh, you're an IT professional.
Yeah, it's my IT professional at the academy.
Okay.
Yeah.
All right. Thanks. Yes, and the importance of maths. Prof has talked about counting and the political significance of maths. Yeah, the electoral importance of, you know, even I suppose, you know, managing our country, managing communities, managing organizations. Knowing how many people are in the organization, the resources at your disposal, and so on.
We can't get away from math, right? We can't. Our lives, as Prof said, is how many is a fundamental function. We live by what time, we live by when, we live by how much. It's all part of it. And you see, we're at a stage where we're all really eager as Ghanaians and Nigerians to move our countries and our continent forward. We're not going to do that very quickly without math, without STEM, right? I always tell people that post-independence, Kwame Nkrumah University of Science and Technology was set up for the very reason that you need science and technology to industrialize, to move forward. We're in an era now where we're hungry to move that agenda forward. Something was achieved then, there are more things to achieve. It will help us solve our fundamental issues and get things right. I say to people, for instance, that when we go to a hospital and there's a shortage of hospital beds, it is not a medical problem. It's a problem of mathematics. Because with mathematics, you can measure the data points historically and say, okay, normally in January we need this many, in February, and then the next year normally that number grows by 5%. So I predict.
And during the rainy season, when there's stagnant water,
I don't know, cholera goes up, and so then I get 100 more people. So with mathematics, you can predict how many beds you'll need in December, how many beds you need in May next year, and then you can plan. So that's not a medical problem. It's not a problem for a doctor to solve. It's a planning problem that says, okay, next year I'm going to need 5,000 more beds. The next question is, how do I fund it? Where's the money? The next question is, how long do I need to produce those beds? So you start to see. And
same with population growth.
Same with power.
Exactly.
Same with power.
Exactly.
So this might interest you. Do you know that single spine failed because of lack of understanding of mathematics? The single spine that we introduced in Ghana, it was all an issue of mathematics, fractions. That's all. That's all.
Okay.
You didn't understand it, you didn't apply it well, that's why the whole thing failed. That's why the spine collapsed.
I guess we've got to about wrap it. So I'll give you, just come round, final thoughts on why we need maths and science.
We need math because we need to be mathematically literate, numerate, to do many things around us. Like we're talking, many of the things are not issues of like the hospital, the whatever. It's management, counting, number problem. That's what we need. The economy is all number.
Right.
Talk about it, everything is number.
Well, the budget.
So we must understand number properly and apply the number well to make sure that everything is done efficiently. And it starts from the secondary school. Make sure the students understand mathematics. Even from primary, start from there. They must understand the mathematics, the relevance of mathematics to everyday things they do.
The relevance of
everywhere is mathematics. So how is mathematics related to even the steps you are building? Why do you build a road? 1 kilometer, then the pothole starts. You build a road, a new road, then 1 kilometer from the new starting point, there's a pothole.
Because?
They're not using mathematics properly. There's a mathematics of it.
Explain.
Oh. Have you seen the bitumen?
Yes, I understand. Yes. I want you to explain.
You see, it's very small because there's a weight of the cars that pass over that road.
Right.
So you must know the correct amount of this thing that must put on it.
Yeah.
But what happens? When they give the money, they take 70% to go and buy Mercedes-Benz, do other things. And then they take only 30% to go and build the road. They just throw dust on the road and then they build the road. So after some 30 meters, the road starts developing when the heavy trucks pass on. So we need to make sure that we understand the significance of mathematics in everything that we do.
Okay.
If you look carefully, you look at somebody, we have what we call mathematics for national education and development. If there's time, I'll talk even one day on that issue for you.
I know. Jane.
I think I'll just wrap up by saying that we need maths personally, because sometimes if you see it for the value you get, you'll probably be more interested. Because you work one day, you need to know why are you earning money and your salary is disappearing. Maybe you're spending more than what you're earning. That's all math. When you have the math right, you know that I cannot earn, say, 400 Ghana cedis and spend 600. That means I'll end up owing. So if you can see personally that it will be value to yourself,
right,
I think it will show some interest.
For
me, just say a couple of things. First of all, I think that I would encourage everybody listening, parent, child, teacher, whatever, math is a fundamental requirement for our lives. I think we've demonstrated that sufficiently, that we need math. And so let's encourage everybody to participate in math. It's about building the building blocks of how we function. It doesn't mean that you have to go all the way to, calculus, or you have to go and do, there's math that I don't know, right? There are levels of math. If someone has a PhD in maths, like Prof, probably the math he knows I don't know. There's a level of math for everyone. Embrace math. There's a basic that we all need to know, and then there are levels that pertain to what you want to pursue in future. Get comfortable and acquire the level of mathematics you need for your professional success. I remember, talking to a group of children with an actress, and she told them to their face, I haven't asked her permission, so I won't mention her name, but if she's listening, she'll know who she is. She says, I didn't pay attention in math, and now when I get paid, I can't, dealing with the taxes is a problem.
Taxes?
Yes. And I have to depend on an accountant, and whether what he's saying is the case or not, I just have to believe him. It's basic. If you want to even be an actor, whatever you want to do, you need a degree of comfort with mathematics. The other thing I'd add, the reason why it's so important is that it helps develop, our ability to think critically, to analyze problems, to look at situations and really break them down. And again, I think I'd argue that regardless of what profession you end up in, even if you end up, wanting to be a stay-at-home parent, male or female, your household runs on mathematics. You have budgets, you have to cook, you have timing, you have so many things that that require you to be comfortable enough to plan with mathematics. So let's throw out the whole notion that it's too difficult. There's math for everyone. There is a level of mathematics that you can
for everyone, in everything.
In everything, exactly. There's a level for you, and you'll need it.
Can you imagine the amount of conflict that women have with their seamstresses? Just because of measurement. A lot of conflict. Because they don't measure well. It's too tight, too big, too something, too short. All the time, they don't measure well. They don't measure well. Oh, yeah, no. I'm not saying, I'm not excluding men. When I say seatbelt, I mean,
yes, yeah.
When it comes to measurement, there's a problem. Even when it comes to cooking.
I didn't right measurements.
You know, you need a certain amount of soup, certain amount of salt, you know, pepper, all of those things to give you the taste you want. But
and the salt is right, and the pepper is not too hot, and so on.
It's measurement, it's mathematics. So you see, we don't have to joke with mathematics at all. We are doing that at our own peril. That's why you see everything in Ghana is shoddy. Because we don't apply the principles and methods of mathematics to the things we do. It's all over.
Precision.
I've just gotten tired of saying that. Look at the flooding. It's all about slope. Slope, flooding. You go and study the y, the x, all of those integration, differentiation. But it's all slope, simple slope. We don't get it. You know.
Or we don't apply. We're not applying it when building the infrastructure.
Yes. You know.
Even sometimes the bathrooms, you know, if you don't slope it nicely.
Right. Yeah. The drainage is not effective.
Small issue of ratio, proportion. We don't do that. See, Melcom building will go and collapse because of ratio. We don't get it. You see, because it's a ratio of sand, cement, water. If you don't get the correct ratio, you will get the wrong strength of the concrete. Bakers, when they bake
and put the wrong weight on
top
of it.
It's all mathematics. You are baking, you know, ratio of water, margarine, flour. You start up, say you are going to make butter bread. You start with the wrong mixture, everything. You go and get a chombo. It's happening. You get a chombo. I say you want butter bread. Because of mathematics is bad. That's all. You see, we joke with these things. We joke with them, but they are causing us very seriously. Very seriously.
That's true.
We think it's for fun, but it's a very serious matter. And we have to go back to the basics, the fundamentals, and make sure these things are taught well and understood with the context of application. You must know how to apply them. You see, I can give another example. Some lady was a baker, and was using, you know, centigrade thermometer.
To measure.
Yeah, to measure the temperature of the oven. And then it got spoiled when she got a very big order. And as the son was finished, first degree university, was enjoying holiday. I said, oh, son, come. I've got this problem. My neighbor gave me a Fahrenheit thermometer.
So to convert
how can I convert the temperature from 80 degrees centigrade to Fahrenheit? Do it for me. That's the only help I need from you. And he went and calculated and got some value for the mother. That value, when the mother baked, the whole thing became charcoal.
Wasted education.
You see? So, if you have gotten mathematics degree level, you cannot convert, you know, from centigrade to Fahrenheit for your mother. That's all your mother needs from you. You can't do that. After all your money mother paid for you to go to school, you cannot do this simple thing. Then what's the point? What's the point?
Yeah.
So the mathematics should not be joked with. We must make sure that a very serious revolution to make sure mathematics is fun. Why understand it, enjoy it. Come and visit my academy.
I will. Thank you very much, Prof.
My pleasure.
Maths can be entertaining as well.
Oh yeah,
very
absolutely, so much.
I just found.
Yes.
After over 40 years, I discovered. Thank you, Lucy.
My pleasure.
Jane,
thank you for having us.
And Prof. Anku.
It's been fun.
And thanks for watching and enjoy math. Dance to math. Sing math.
Have fun with it.
Have fun with math.
Yes.
Good night.
The Lounge, proudly brought to you by Johnny Walker. Keep walking.